Hey guys, it's Miss Puett, and I am out today on a field trip. I know, gone yet again, but promise I'll be there on Wednesday. Today you're actually going to be learning something while I'm gone. I use this program called Screencast-O-Matic, so you guys can still learn while I'm out of the classroom, so you're not doing more of those sub-worksheets. Okay, so today you're going to be learning a new lesson. This will not be on the test tomorrow. Again, it's not going to be on the test. So this is based on polynomial. Ooh, if I can do it correct. This is based on polynomial expressions. Can you guys say polynomial expressions, please? Perfect. So go ahead and make that the title of your notes. So go ahead and pause so you can write the title, and I'll just wait. Okay, so pause is done. So welcome back. All right, so with polynomial expressions, first off, a polynomial expression looks something like polynomials that might look something like it's an equation form. So what I mean by that is expression we've studied before. So something like 3x plus 4x. That could be an expression because you're just simply combining like terms and there's no equation. As soon as you make an equals, let's say 15, that's what makes an equation. So expression, you're just going to be looking at similar objects and combining them. So in this case, exponents on variables. So that's what polynomials are. So going to the next slide, the key focus right now is on monomials. So can you guys say monomial, please? Perfect. So a monomial is a real number, variable, or product of a real number and one or more variables. So it's a huge definition there, huge. But I'm going to be giving you a lot of examples to make it a lot easier to see. Okay, so examples of monomials are right here, and these are not monomials. So a monomial is, again, a real number, like 5, a variable, like x, or a product of a real number and one or more variables. So 5x, 5 is a real number, x is a variable, there's a product right there. Same thing with x and y, they're both variables, product because you're multiplying them. X to the power of 5, product because it is x to the power of 5 is the product of x 5 times, which is x times x times x, and so on, 5 times. So anytime you're looking at a real number, a variable, or a product of two of those things, that's when it's a monomial. So not a monomial would be something like something other than multiplying. So x plus y, you are not multiplying them. It's not a product. That's why it's not a monomial. Same thing with 1 over x. So x right here, x is a variable, but you want to make sure that the variables have whole number exponents. Right there, that's key. So -1 is not a whole number. Remember, the whole numbers would be something like 0, 1, 2, 3, ... and it keeps going. So on the next slide, you're actually going to see some basic examples. I also included a description, so it makes it easier for you to add extra things. So right now, I'm just going to pause while you guys go ahead and determine if this is a monomial or not. Okay, so this is without a doubt a monomial. The reason it's a monomial, it's going to work. The reason it's a monomial is because you have a real number -9 and it's multiplying two variables. So there you go, this is monomial. How about 3a squared minus 2b? No, that's definitely not a monomial because you are subtracting. It's not the product, you're not multiplying them. Once you're subtracting, adding, doing anything other than multiplying, it's a no. How about 3 over 4? Yep, 3 over 4 is a monomial because 3 over 4 is a real number. If you can think about something existing, like 3 over 4, you can have a 3/4 cup of flour. It can exist, it's real. That means it could be a monomial. So this is actually not a monomial. The reason is actually because right here. So if you were to rewrite this, we see d squared in the denominator. That means that this could also be written as 6t times d to the negative 2 power. Remember how we learned about negative exponents? You want to make them positive, you throw them in the denominator. Because this right here is a negative 2, remember your variables have to have whole number exponents. Negative 2, not a whole number, because it comes before 0. Okay. How about this one? Yep, this one is a monomial because your 8, that's totally fine. If you were to rewrite this, you would have 5n squared times 8 to the negative 1 power. It's okay for, what do you call it? It's okay for whole numbers or real numbers to have a negative exponent. It just can't be the variables. Okay, how about the next one? Nope. If you were to rewrite this, this is the same as h to the 1/2 power. Remember our square roots? 1/2 power, it's a variable, but you have to have a whole number exponent. 1/2, not a whole number. And the last one. This is a yes. A number of 5. If you were to rewrite this, this would be 5 to the 1/2 power. This is not a variable, so it can have an exponent that's not a whole number. So those were just some practice. Okay, what if I asked you to explain why 18 to the 1/4 is a monomial and x to the 1/4 is not? So think about how you'd answer that, and you can go ahead and pause the video. Okay, so to give you overall reasoning, 18 to the power of 1/4 is a monomial because that 18 to the 1/4 power, 18 is indeed a real number. Real numbers can have something other than a whole number exponent. When you see x, x is a variable. Variables have to have a whole number. Sorry, that's my daughter. Variables have to have a whole number exponent. 1/4 is not a whole number. Okay, how about x to the 0? Is that a monomial? That is a monomial. Remember, anything to the power of 0, anything is 1. You could have 5 to the power of 0. You could have 1500 to the power of 0. Anything to the 0 power is 1. So therefore, x to the power of 0 could also be a whole number. Okay, so when we simplify, we're going to have to remember our rules of exponents. So product of powers, power of a power, our whole last unit focused on that. So what we're going to do here is these are 2 examples, so I'm going to do them. I'm going to have you write them in your notes. I'm going to give you some practice examples. I'm going to pause so then you can do them. Okay, so starting here, we have x times x. So if I think about product of powers, you actually have the same base here. So this is x to the power of 1 times x to the power of 1, if you want to think about it that way. Because if you think about it that way, product of powers means that you have to add the exponents. So that would mean 1 and 1 makes 2, or x squared. So x times x, a lot of people think, oh, that's 2x. Well, no, it's not 2x because when you're multiplying the same base, you have to add the exponents. Okay? So this is an example of where you'd actually have to multiply coefficients and then worry about adding exponents. So I have 3 times negative 4. So if I multiply those, that'll give me negative 12, easy enough. And then I have x times x squared. So if I think about going back to my previous example, if I see just an x, it's implied that there's actually a 1 exponent there. So this is the same as negative 12, x to the power of 1 plus 2, or negative 12, x to the power of 3. So that's the final answer on this one. Okay? So I'm going to give you a couple practice examples, and I will go ahead and give you time, so pause the video once you see the next ones. Okay, So unpause. You should have been able to have time to kind of look at these. Oh, just kidding. These are examples. Okay, my bad. So these are looking at power to a power. So power to a power means that you multiply them. So whenever you have a parenthesis separating two exponents, you have to multiply the exponents. So this is the same as x to the power of 4 times 3, which is x to the power of 12. So boom, that one's done. So here we have actually a coefficient to worry about other than the variable. So two ways you can look at this. One way is you can look at 3x separately and then apply that 2 to each of those terms. Kind of like when we had our fraction problems and you had to look at applying anything within the parentheses to that power on the outside in our last unit. Same thing goes here. So that would mean this is just going to simplify to 3 squared, which is 9x squared. So that's one way you can do it. Another way you can do it is by noticing that you're actually squaring something. So you're multiplying something twice. So that would be 3 times 3, which is 9. x1 times x1, add the exponents, makes x squared. So either way, you're still going to get the same thing. So here's your first practice. So I'll go ahead and pause it. Okay, so this should have been the final answer right here. You multiplied -5 times -4 to get your positive 20. T cubed times t makes t to the power of 4. Here's your next one. So go ahead and pause it. Okay, the answer on this one, you have two ways to look at it. -4 squared is -4 times -4, which is positive 16. D squared is d times d to make d dose. There you go, d squared. Okay, we're going to try a couple more. So these are practice ones, so go ahead and try this one. Go ahead and pause it. Okay, so one way you can look at it, before I get to the next one, one way you can look at it is 2 to the power of 3, which is 8, and then n multiplied by itself 3 times to give you n cubed. So try this one on for size. Okay, so that one, 7 times -2 makes your -14. y5 times y squared, add the exponents to make y to the power of 7. Okay, so polynomials, it's looking at a monomial or a sum of monomials. So each of these three are different types of monomials. It's all based on how many terms that they have. So monomial has one term, binomial has 2 unlike terms, trinomial has 3 unlike terms. So what I mean by unlike right here is after you've combined like terms, you can't combine any more. How many terms do you have left? That determines what it's going to be. So let me go ahead and show you. So this right here is actually going to be considered a binomial. The reason it's a binomial is because there are 2 unlike terms. You're looking at there you go. There you go. T-E-R-N-S. There you go. So 3x squared, 5x, even though they do have an x, they do not have the same number of exponents. So try this one. So this right here is actually going to be a trinomial. I'll just go ahead and show you the words. So it's a trinomial because you have 3 unlike terms. You have an x squared term, an x term, and just a constant. That's why it's a trinomial. So something like, there you go. Something like this would have to be a binomial because you have 2 unlike terms. So I can go ahead and move that out of the way so you can see it now. There you go. And then finally, this would be a monomial because you have only one term. You have a real number, you have 2 variables that you are multiplying. That's what we're actually focusing on the beginning of the lesson. That's why it's just monomial. So I'm going to have you try this one. Okay, that's a binomial because there are 2 unlike terms. Monomial because there's only one term. Trinomial because there are 3 unlike terms. Okay, so I'm going to be running out of time here, but standard form just means you're rewriting each of these, where you have your greatest term